In the first part of this presentation, we're going to look at the main roles of the ear. What does it do? We'll start off by looking at the basic roles of the external and middle ear. In the second part, we'll look at what the inner ear does. The main role of the auditory system is to pick up sound vibrations in the air and extract meaningful information. The first part of this process is to analyse the sound into the basic building blocks, such as frequency, intensity, timing, and location of the sound source. Once this information has been extracted, the higher parts of the auditory system in the brain can group components from the same sound sources together into sound objects, and the brain can then extract identity and meaning from the different sound objects. In these presentations, we'll concentrate on the initial parts of these processes carried out by the ear itself, as it is damage to these peripheral stages that is the cause of most common types of hearing impairment. The main role of the peripheral auditory system is to convert sound waves in the air to nerve impulses, and in the process of doing so, break down the sound into different frequency components and pass this information, along with information on intensity and timing of the components, to the brain. The auditory periphery, or the ear, is divided into three parts. The external ear, which consists of the pinna and ear canal, which serves to collect the sound coming into the ear. The middle ear, which allows the vibrations of air molecules that make up the sound waves to be efficiently transferred to the movement of the fluid in the inner ear. The inner ear, or more specifically the cochlea, is the sense organ for hearing that breaks down the sound into the component frequencies and converts the mechanical vibrations caused by sound into firing of the auditory nerve fibres. This diagram shows the basic structure of the peripheral auditory system. First of all, the sound is collected by the external ear, the pinna, which funnels the sound into the ear canal and directs it down to the eardrum, or the tympanic membrane, in the middle ear. The sound then travels via the middle ear bones, or ossicles, through the middle ear to the snail shell-like structure of the cochlea in the inner ear. It is the sense organ within the cochlea that stimulates the auditory nerve to fire. We will look at each part of this chain over the next few slides. The external ear is made up of the pinna and the ear canal, and together they serve to gather the sound, rather like a funnel, and direct it to the middle ear. The external ear also has a protective role, in that it allows the delicate middle and inner ear to be away from the surface of the head. Also, the hairs and wax in the ear canal help to prevent foreign bodies from entering the ear canal. The complex shape of the pinna has a role in localizing sound, particularly in the up and down or vertical direction. Blockage of the external ear will reduce the amount of sound arriving at the middle ear and result in a conductive hearing loss. The sense organ of hearing, the cochlea in the inner ear, consists of a tube filled with fluid. If sound travelled from the air directly into the fluid, most of it would bounce back at the surface or be reflected. Only about 0.1% of the movement would pass into the cochlea. The middle ear, which is made up of the eardrum, the tympanic membrane, and middle ear bones, or ossicles, the malleus, incus and stapes, allows for efficient transmission of the sound vibrations from air to the fluid of the inner ear. Any blockage or break in the ossicular chain will reduce the efficiency of this transmission and result in a conductive hearing loss.